Um, Now, lab, designing and implementing IPv4 addressing with VLSM. Um, we use 1941, a router 1941 of 3, 1, another 1941, and another 1941. Um, we name it, this one is HQ. This is HQ router. This is um, this is branch 1 router. BR1, and this is branch 2 router. BR2, and we use a serial cable. This side is a DCE, so we go here and a serial cable with the clock rate, because this is where the DC, where this is where going to be the clock rate, and this is serial 0/0/0. I forgot to add the serial module here first. We click here and we add this module. So this module here and this module here, and now we turn it on, and now we should be able to see the serial interface now. And likewise we do in HQ and BR2. I'm going to be doing this in off screen. Now after adding the module, we should be able to see the serial interface. We go to the here, we get serial, this is going to be serial 0/0/0, and this is going to be also serial 0/0/0. Now, and this side of this router is going to be DC side, where we have the clock rating. So this is going to be serial 0/0/1. This is 0/0/1, and this is going to be also 0/0/1. 0/0/1. Now we have another clock rate in this side of this branch 2 router. So it's going to be serial 0/0/0 and serial 0/0/1. Now we're going to be doing the examine the network requirements, part 1. Um, Now in part 1, you will examine the network requirements to develop a variable length subnet masking address scheme for the network shown in this topology diagram using the network address 172.128.0/17 network. Note that you may use the Windows calculator applications and www.ipcalc.org IP subnet calculator to help with your calculations. Um, First, determine how many host addresses are available and how many subnets are needed. So it is a /17 network. So if we go this table, we can see the /17. And for the /17, the total number of hosts is going to be 32,768. 32,768, and out of this first one is going to be the network address, and the last one is going to be the broadcast address. So we have only 32,766 hosts. So when the question is how many host address are available in a /17 network, the answer is going to be uh, 32,766. Now, what is the total number of host address needed in this topology diagram? What is the total number of host address needed in this topology diagram? We start from HQ routers, and it has a gigabit 0/0, which they need 16,000 hosts, and gigabit 0/1 need 8,000 hosts. Um, so how many IP addresses? What is the total number of host address needed in this topology? So we have here uh, HQ routers and the gigabit 0/0 interface in a 16,000, and gigabit 0/1 in 8,000, and then you have a branch one, uh, gigabit 0/0 you have a 2,000 in it, and gigabit 0/1 you have in it 4,000 here, and then branch two you have a gigabit 0/0 500, and 0/1 is 1,000, and then you have a HQ to branch one, you need two hosts here. You need two IP address, one over here or one over here. So you need two hosts. And HQ to branch two, you also need two hosts, one over here and one over here. And then branch one to branch two, you also need two hosts, one over here, another one over here. Um, so now how many subnets are needed in the network topology? So let's find out the subnet. We know that we need 9 subnet. 1, 2, 3, 4, 5, 6, 7, 8, 9. But let's find out the host address and network address and broadcast address of all those the, of all those hosts that we need. So first, the HQ routers on gigabit 0/0 interface, we need 16,000 hosts. So for 16,000 hosts, what is going to be the subnet masking? This is the 16,000 host. It falls in this range. So for this 16,000 host, we need /18 subnet mask. So for the gigabit 0/0 interface, uh, this is the this is for the gigabit 0/0. We need /8 for this 172.16.128.0. We need /18 for 16,000 hosts, as we have mentioned, /18 um, for 16,000 hosts. This is where it says the /18 for 16,384. So it falls into this category, into this range. Um, so the network address is going to be 172.16-128 172.16.128 dot 0 and slash 18. Now let's calculate the network range of 172.16.128.0 slash 18. Now the subnet mask for slash 18 is going to be 255.255.192.0. And now we write the network address right underneath that, right underneath uh, 172 dot 16 dot 128 dot 0. Now first we focus 255 octet of our subnet mask. Below that is going to be part of our network address which will not change. So we write this this 2 octet because 255 this is not going to be changed. So we write 172.16. This is going to be remain constant um, throughout their network scheme. 172 16. Now we now focus uh, zero of the we now focus on the 0 octet of the subnet mask. We place 0 on the subnet, and down on the broadcast address we place 255. So 0, this is the subnet, this is going to be the subnet, and down on the broadcast we place 255. So this is the subnet and this is the broadcast. We are focusing the 0 octet of the subnet, and the subnet portion we have um, we place 0, and in broadcast portion we place 255. Now, and these are the third octets. So now we are looking for the number to fill it up in this octet. Now we focus. Now we focus 192. Now we focus 192 on the third octet. We have to find our magic number. We subtract 192 from 256. So we have to subtract 192 from 256. So we subtract 192 from 256 and we get 64. So in this case, this 64 is our magic number. So we need to increment 64 starting from 0 until we go to the number that is equal to 90, that is equal to 128 or not greater than 128. As you can see, as you can see, 64 fits uh, its criteria nicely. Sorry, this 128 fits this criteria very nicely because we increment 64, so the next number is going to be 64 and then 64 128. So 128 is equal to or not greater than not greater. So we pick that 128 and fill that gap here. So 172.168.0 is going to be our subnet address. Now we have to look for we have to fill up the gap here for the broadcast address. Now our last bits in this range is going to be the next subnet address is 128, and then next one is going to be plus 64 is 192. So our last bits here is going to be 191, because the next one is going to be 192. So the one before 192 is 191. So we simply take this last bits and um and put it in our third octet as a broadcast address. And now we have to determine our first and last valid host range. First and last valid host range. We first have to start with first. Obviously, we start with subnet 96 and bring it down and add one. Add one. So when we add one to the 0, it is going to be 1. And now for the last valid host address, we start from broadcast and work up from 191 of the last third octet. We bring it up simply here, 191. Now 255 is the last octet, and we subtract 1, and in this case is going to be 254, 254, and we fill up the space with 254. So for HQ gigabit 0/0 for 16,000 hosts, our first host, our network is going to be 172.16.128.0, and our first host is going to be 172.16.128.1, and our last host is going to be 172.16.191.254, and broadcast address 172.16.191.255. So the host range is going to be 172.16.128.1 to 172.16.191.254. So we write that for HQ gigabit 0/0, the host range. So it is going to be the first host address is going to be so first the network address is going to be uh, network address is going to be 172.16.128.0, and then first host address is going to be 172.16. Let me put a tab here so that we have some space. 172.16 um, 172.16 dot 128.1, and the last host address is going to be 172.16.191.254. So this is going to be our host range. 172.16.128.1 to 172.16.191.254. Now for HQ gigabit 0/1, we need 8,000. We need 8,000 hosts. And when it's in 8,000, if we go to the chart for the 8,000 hosts, what is going to be the subnet mask? It's 8,000 hosts is in this range. So subnet mask going to be /19. So 172.16.128 dot um, 0, and then it's a /19. So if we apply the same arithmetical principles, we get our host address is 172.16 dot 16.192.0 is going to be our network address, and it is /19. And what is going to be the first host address? 172.16.192.1 is our first host address, and then our last host address is going to be 172.16.191.254 is going to be our last host address, and broadcast address is going to be 172.16 dot 223 dot 254. So this is going to be our broadcast address. Now let's explore how did we get our first and last host address and the network address. Um, our the HQ 0/1 has a 172.16.128.0/18. So 128.0, the next network address was supposed to be um, so next network address was next subnet is going to be 172.16 dot, so it was a /18, so network goes up by 64. So 172.16, 128 plus 64 is 192. dot 0, and since it's a 8,000 host, it is going to be not slash 18, it's going to be slash 19. Now we apply the same principles that we used before and find this address. Let's see how we apply these principles. So for a slash 19, the subnet mask is 255.254.0. So we put subnet address here, and we focus on 255 of our subnet mask. Below that, that is going to be part of the network address, which will not change. So nothing changes here for 255. So we put 172.16, 172.16, 172.16, 172.16, because this column there's going to be no changes. Now we place 0 on the subnet, and in the broadcast address we place 255. This 255 is on the last octet and 0 is on the last octet. Now we need to fill these third columns. Now we focus on 224 on the third octet. We have to find our magic numbers, and we subtract 224 from 256. So after subtracting, we get our magic number, which is 32. Now we need to increment now we need to increment 32 until we need to increment 32 starting from 0 until we get to the number that is equal to or not greater than 192. So as you see that 224 fits this criteria nicely, because 32, sorry, I said 224, it's not 224, it's 192. 192 fits this criteria nicely, because 532 is going to be 5 into 32. So 6 times 32 is going to be 192. This is why 192 fits this criteria. Now we pick this 92 and we pick this 92 and fill it in the blank 192. Now our last base in this range is 224, because 192 and the next 192 plus 32 is going to be next subnet. So 224 is our next bit range. Sorry, our next bit range is not going to be 224. It's going to be 1 before 224, which is 223, and we simply fill it in the blank in the broadcast range. So now we get our broadcast address 172.16.223 dot 255. We now have to determine our first and last valleys host range. Now we first have to start first, obviously. We start with the subnet. This is the subnet, and bring it down and add 1, 0 plus 1, and we fill in the space. So we put 1, 0 plus 1 is equal to 1. And when we say we add 1 from subnet, um, this 19, we have to fill this third octet, the first valid host, with 192. So 172.168.191 is our first host address. And for the last valid host address, we start from the broadcast address and work up. This is the broadcast address and work up. So from 223 in third octet, we bring that up, put 223, and the last octet from 255 we subtract 1, which is 254. So our valid host range is 172.16.192.1 to 172.16.223.254. Now, for branch 1 and gigabit 0/1, we need 4,000 hosts. So this is the branch 1, and for the gigabit, there's these pictures. So this is the branch 1, and for the gigabit 0/1, we need 4,000 hosts, and gigabit 0/0, we need 2,000 hosts. So for the 4,000 hosts, let's look at our tables. For 4,000 hosts, it falls into this range, and it is /20. So this is going to be a /20 subnet mask. So when it was a 19, the next the network goes up by 32. So from previous 19, the next one is going to be um, when it was 19, it was 192, and then next network is going to be 192 plus 32, which is 224. Next network is going to be 172 dot 16 dot 224 dot 0, and this is going to be /20 for 4,000 hosts. And if we use the same mathematics, we get the network address is 172.16.224.0, 172.16.224.0, and then our first host address is going to be 172.16.224.1, and a last host address is the broadcast address is going to be 172.16 dot 339 dot 255 And the last host address is going to be 172.16.339.254. We applied the same formula when we calculated the subnets for first host range for HQ gigabit 01 and HQ gigabit 0. Uh, Using the same formula for the branch, using the same formula for the branch 1 gigabit 0/0 for 2000 hosts, we get 172.16.240.0/21 for 2000 hosts, and we get our network addresses 172.16.240.0, and then we get our first host address 172.240.1, and then we get our broadcast address 172.16.247.255, and then the last host address is 172.16.251.254. No, it's 172.16 dot 172.16.247 dot 254, and these are all slash 21 networks. Now we move on to branch 2. For branch 2 gigabit 0/1 for 1000 hosts, we get the network address 172.16.248.0, 172.16.248.0, and it's slash 22 for 1000 hosts. So our network address is 172.16.240, but 172.248.0, and then our first host address is 172.16.248.1, and then our broadcast address is 172.16.251.255, and then last host address is 172.16.251.254 dot 254, and these are all /22 network. And using the same formula, so we get a branch 2 for branch 2 gigabit 0/0 for 500 hosts. We get our network address 172.252.0, and then first host address is 172.16.252.1, and then our broadcast address is 172.16 dot 172.253.255, and then last host address is 172.16.253.254, and these are all /23 network. Now HQ to branch 1 for the two hosts, we get 172.16.254.0, and it's a /30 network for two hosts. And first host is going to be 172.16.16 172.16.254.1, and then broadcast address is going to be 172.16.254.3, and the last host address is going to be 172.16.254.2, and these are all /30 network. Now, using the same formula, we found out that these are the subnet and host range for HQ to branch 1, which is two hosts. Subnet is 254.0, and 254.1 is the first host address. The last host address 254.2, and the broadcast address is 254.3. And using the same formula, we can get two host range for branch 2, HQ to branch 2, and branch 1 to branch 2 host, and these are the host range.